All right. How's everybody doing? Good. Excellent. So I'm told I'm supposed to stay within the confines of this box. I can't move. Okay, let me turn it. This way? Is it better? Here's something. Okay. Excellent. So this is a talk that Ed Cray and I prepared for Agile 2015 conference. And we gave it at the conference, and a lot of people liked it. And Heidi, thank you. Thanks to Heidi, she invited us to come and speak here. And unfortunately, Ed couldn't make it. So I will do the best Ed impression that I can. My name is Stas. I'm an architect with Yahoo. Been with Yahoo for 13 years. Feels like an eternity. And I've done various things at Yahoo. Most of my time I spent with advertising and data platforms group. And I'll talk a little bit about that group, actually a lot about that group as part of this presentation. Why do you work where you work? Is it the money? Probably, this is a very hot market. You could probably go and find a different job that pays more. But you wake up every day and you choose to go to your place of work. Why do you work where you work? Goats. So Yahoo is located in the Bay Area, right by San Francisco Bay. And next to our campus is a hill. And 10 months out of the year, the hill is brown. And for 2 months, the grass is actually green. And if you don't cut that grass, it becomes a fire hazard, so the grass has to be cut. It used to be the city of Sunnyvale would bring in equipment. They would hire somebody who would come in and mow the lawn. And it would be very noisy and very distracting and bad for the environment, right, all the fumes, and cost the city money. So one day somebody had this bright idea to bring in goats. So what they bring is, there are people that have goats. So they bring in goats for free. City doesn't have to spend money. Goats get fed, they're happy. Good for the environment. The lawn gets fertilized. So every year the goats come in and it's an event. They're only there for a couple of days, but we all come out and we start taking pictures. So it was, I think, first or second day that Ed and I started working on this presentation. It's in February of this year. And we look outside. The goats are back. Wouldn't it be cool to include pictures of goats in our presentation? Let's go take pictures. So we came out and we started taking pictures. So what you can see here is you can see our campus and the goats over there on the hill. A couple of things to notice. They're enclosed, right? So we want them swarming on one task, right, on one patch of land. And tomorrow we're going to give them a different patch of land. And so that they don't run away, they're enclosed. There is fence around them, right? And they tend to just wander around. And the fence is electrified. So if we have any engineering managers here in the audience, think about it. So we're taking pictures, and here's Ed, it's me taking pictures of Ed taking pictures, and now I'm continuing taking pictures, and I hear behind me, ouch! Turn around, it's Ed. He got electrocuted. But don't worry, he survived. But he will never be the same again. Let's all agree. We all want to take pride in our work. We all want to ship frequently and delight our customers and learn about our products and make them better and delight them even more. We all want to ship with quality so that those customers don't run away. And we all want to do meaningful work. Nobody wants to do monkey work. So let's start with a show of hands. Raise your hand and keep it up if you launch to production at least once a year. It should be everybody. Keep it up if you launch to production at least once a quarter. Once a month. Once a week. Once a day. Okay. That's good. That's good. I do this all the time, and there are very few people who launch more frequently than once a week. Let's do another show of hands. Raise your hand if you're insanely proud of the quality of software that you put out to production. Let the record show. One. And I'm not sure if he's serious. Okay, raise your hand if you want to be insanely proud of the quality of software. So we all agree. What if I told you? There was a way for you to dramatically improve your quality and save a bunch of money in the process. The answer is Hawaii. So here's what you do. You take your QA team and you buy them an all-expenses paid trip to Hawaii. First-class tickets. Nothing but the best for them. Best resort. All expenses paid. Put them on a plane. Send them there for a couple of quarters. They've been working very hard. I'm not joking about this. You work them to death almost. Send them to Hawaii. Take away their laptops. We want them rested. And when they come back 2 or 3 quarters later, I guarantee your quality will be better and you will have saved a bunch of money in the process. Yahoo. Yahoo is 20 years old. What were you doing 20 years ago? Just think about it. I was on 14K modem on America Online 20 years ago in my room. Try telling kids today that you can't pick up your phone when you're on the internet. What does one have to do with the other? The notion of connecting to the internet doesn't exist anymore. So that's when Yahoo started, 1995. And in the first 5 to 7 years, it was the explosion of the internet, the gold rush. So all the properties of Yahoo that we've known for all these years, news, finance, sports, messenger, mail, they all started during those years, between 1995 and 2000. And they still exist and they're still running. We were moving so fast. We were like speedboats. We were launching nonstop. But then something happened. The software got more complex, product got more complex. Somehow we slowed down. We slowed down. It was so bad at some point. We had teams that launched only a couple of times a year with a lot of pain. And we tried to get out of that mess. We tried to get out of that Tarpit. And we couldn't for many years. And we tried, and we tried, and we tried. And it took us many tries, but eventually we found our way out. And today, we're competing again. So this is the presentation. That is the journey that I'm going to talk about. In 2011, this is when ads started, just as he started. Our sign came down. In San Francisco, if anybody was in San Francisco before 2011, you probably saw this sign. As you approach the city on 101 and you make a turn for the Bay Bridge, right next to jail, there is this big Yahoo sign. There was this big Yahoo sign. And we had some quirky messages on it over time. Hi, Mom, this and that. And in 2011, it was turned on. And by many, it was seen as a powerful symbol of the demise of Yahoo. And it was largely true. The best example that I have is the example of my team, of my organization, ads. We were building an ad product. An ad product, our customers were Yahoo, but also a lot of external customers. Every day we would serve, at that point, 500 million unique requests. We would process more than 100 billion unique events every day. Just to give you an idea of the scale, you take each one of those events and you process them for a second, it would take you more than 5 years. Massive systems, hundreds of unique software components, millions of lines of code, and we were slow. Many years ago, in an office far, far away, where I was working, my manager calls me, said, hey, let's go have a coffee, have something to discuss. So we get together, he says, the CTO has been talking about this thing called continuous integration. And yeah, we all understand what it is, we're not dummies, but we don't really know what to do about it. Can you take a look into that for the entire organization? And the organization at that time was about 400 people. And I'm like, sure. So I'll take a look. And I'm an architect for this one particular set of components. So I know how that software is put together. I have no idea how the rest of the system, how the rest of 400 people operate. So I figured the best way to go about it, approach the most complex team and find out how they put together their software. Great, and I have a friend on the team. Let's call him Steve. His real name will remain unmentioned. So, Steve, how do you build your software? Oh, so we show up on Monday. So they show up on Monday, and they get their tasks from Linda, the manager, their manager. Monday they show up, Linda gives them tasks, they start working, they start typing. And Steve is a very senior engineer, which means he's a really, really fast typer. So by Wednesday, he's done. So, do we have any developers here? We have developers, I heard about Ruby and JavaScript. So what do you guys do when you're done with your tasks? Test it. So in their case, he checks it in, he sends an email to his manager. That's the protocol. Hey Linda, I'm done. She responds immediately. She's online all the time. Thank you, Steve, so much. I know I can always rely on you. You're awesome. It's Wednesday night. When everybody is done with their tasks, we will be ready for the build. So Thursday night comes around. These are weekly tasks. She sends out an email to the team. Team, I know everybody's working so hard. Just want to remind you that tomorrow by noon, everybody please have your check-ins. We want to have a clean build. So Friday noon comes around, and they're mostly done. Mostly. Couple of tasks have to be completed. And they know that if they miss this deadline, they have to wait for another week. So everybody piles in, and Steve gets involved, everybody gets involved. Teamwork, everybody's happy. 3 hours later, all the tasks are checked in. So Linda sends out this email to the team. Congratulations, team. Thank you so much for working hard. Take a deserved break over the weekend. We're ready for the build. Next, from Linda to Bob, the builder, comes the email. Bob, we're ready for the build. And Bob, you can just imagine him. He's sitting there with his 3 monitors and doing something. Pops up this email. Looks at it, starts a new window. At that point, we were using Subversion. So Subversion checkout, waiting for a long time. Then he types in one command, make, enter. What do you think happens at this point? Explodes. Had no chance of working ever. This thing wasn't integrated for a week. And I'm not even talking about test failures. I'm talking about compilation problems. So by about 3:30, 4 o'clock, he sends out an email back to the team. There's buildy, no worky. And this was not their first rodeo. They branch, they know what to do. They branch immediately and they try to stabilize this thing with branch. And they work over the weekend. Turns out Steve works all weekends. They work over the weekend, Monday, Tuesday, Wednesday, this thing finally compiles. On Thursday, they try to deploy it to an environment. It doesn't deploy it first, takes them a day to deploy it. Friday, they try to start up all of these services because they don't start up immediately. On Monday, QA comes in. They're ready for QA. QA comes in, runs their tests. What do you think happens? You know the answer. It explodes in their face. So they tried to fix it for QA on the same branch that they caught a week and a half ago. Meanwhile, they just got a new branch on Friday, and they're working a new task on their main line. And they continued doing this for 6 weeks. At some point, they said, okay, enough. Let's stabilize. So this was their release schedule. Each cell is a week. 6 weeks of development, 10 weeks of stabilization, 4 weeks of launch. And I wish this was just that team. But the truth is, all of our teams work on this exact schedule. Across the organization, 400 people at that time. 6 plus 10 plus 4 is 20. 20 weeks for the release cycle. If you overlap development and launch a little bit, you can squeeze 3 releases per year. So per year, we could squeeze 3 releases. And I know I'm an architect, and I care about components, and I care about code. But people are people too. And people are in pain. And how much pain? I was just trying to think about how can I express this pain. So I decided to be very scientific, and I bought this very scientific instrument called the panometer. And I used the panometer, and I measured the pain. And the base level of pain is very high. Because what I haven't told you is that in production, stuff is breaking nonstop. So on top of all this craziness that they're doing with branches, there's also production outages. And Steve and folks like him, they're constantly dealing with that. They're in a lot of pain. And on top of that, you add the releases and you see this pain rise towards the release date. Then a couple of weeks of respite, and it rises again. This is what we call the roller coaster of pain. It is immoral to put people on the roller coaster of pain. But we did it. And not because we're bad people. We just didn't know any better. And not because we're complete idiots. The problem is just very hard. So everybody's unhappy. Developers are unhappy, they're in constant pain. Product is unhappy because they're not getting their features, and the features that they get are of bad quality. Customers are unhappy for that same reason. They're not getting their features, and the features that they do have are of bad quality. So when Ed started at Yahoo, he went around, this was 2011, he went around and he interviewed a bunch of people, developers, product directors, you name it. And he gathered a lot of quotes from them. This is one of the quotes. And it pains me to read this quote, but I think it's very fair. It captures the feeling among many people, not just developers, everybody around the table at that time. So, okay, if you don't believe in any of this hippie stuff, pain, people, happiness, just think about it from pure business perspective. 6 weeks of value out of 20-week release cycle. 18 weeks out of the year you're adding value, assuming that you're actually adding value with what you're doing. You're swimming in your own garbage, waste. Yuck. On top of that, product is unhappy. It takes on average 2 years to get a feature out, from concept to production, on average 2 years, sometimes 3 years. If we really focus, it will take us 18 months. We were an elephant stuck in the mud. Our competitors were running circles around us. We couldn't do anything about it. We saw it. We tried to get out. It took us many attempts, many failures to get out, but we found our way out. And as we were preparing for this presentation, we found this quote by Michael Jordan. I think it captures the spirit of those years. Before I can tell you about our attempts, I need to tell you a little bit about our system. I already mentioned that it's a large software system. Imagine that with this software system, you're trying to deploy 4 features to production. Now, underneath, so huge software system, 500 million daily unique requests per day, hundreds of billion, more than 100 billion unique events. You need to scale the system. And one way to scale the system is to break it up into individual systems. Each one is responsible for its own part of the puzzle, and they all work in concert. Right? So underneath, we have something like 15 to 20 massive software systems. Each one of those can be further broken down into individual components. So underneath, within each box, we have something like 10 to 15 to 20 individual components. So massive software system, that's how you scale. And this thing scales, it works. The consequence of breaking up a software system like this is that your features end up being broken up. So you have pieces of features all over the place. It was not unusual to have features that get implemented in 15 different places. That was quite normal, actually. So the thinking is, before you can release this to production, you need an environment. We call that environment end-to-end, E2E. You need an environment where you have that looks and feels just like production, where you test all of this together, and then you go to production. And of course, not complete idiots. Before these systems go into this environment, they're supposed to certify themselves. Problem is, it's very hard to certify features, especially many features if you're developing them in bulk, without all of the other systems being present. Right? You're collaborating with all of these systems for your functionality, but they're not there. So theoretically, you could test the contract, but it's so much easier. It feels so much more comforting if you do it against the real systems. So the truth is that people did only superficial testing, and then they would deploy straight into end-to-end environment. And as the result, that environment mostly didn't work. Remember this picture? That 10-week stabilization period? During this entire period, that end-to-end environment would be up for maybe 2 hours. At the very end, like magic, every time. Towards the end of the release, it would work. It would stay up for 2 hours. We would certify, and then it would be broken again. And then we go to production. That doesn't mean the quality was good. The quality was bad. We knew that. Worse than bad. It was unpredictable. Unpredictable quality. But still, you certify, you go to production because you have to go to production. And launch was also scary. All of these systems, in the huge distributed system, they implemented new features. They started imposing orchestration requirements on each other. And maybe they talk to each other peer-to-peer, but pretty soon you have circular dependencies. So you go to production, you try to launch, and stuff just breaks. And it takes 4 weeks to finally launch it very carefully. So you have unpredictable quality. We have unpredictable quality. We have unpredictable launches. We have Vegas. So what do you do in this case? You can try to improve quality. You can try to improve launches. Where do you start? How do you start to dig yourself out of this? What we did was very deliberate. It was a very deliberate decision that we're not going after improved quality. We're not going after other things. One specific thing that we're going to go after is predictability. We want predictability, even with poor quality. So this was the first iteration. Establish quality gates. Before you enter that end-to-end environments, you have to meet certain quality gates. Before you go to launch, you have to meet launch sequencing. So we established prescribed launch sequencing. Probably not the best launch sequencing for a particular release, but it works. We know that it works. And everybody can conform to that launch sequence. So what this gave us a factor. Now, do you guys know what this car is? Anybody? Yugo. Wow. You're one of the first people to recognize it. So for those of you who don't know what this car is, it's Yugo. Produced in Yugoslavia back in the day. Sold in the United States in the 80s. Notorious for its bad quality. So we have a factory. We're producing Yugos. Bad quality, but we can start iterating from this point on. So the first attempt at iteration was, hey, let's be agile. Let's establish sprints. So 6 weeks of development, let's break it up into milestones, 2-week milestones, and align our features to these milestones. The thinking is, we get these features to create earlier. If they finish early, quality will be better. Eventually, we'll be able to squeeze in more features into a release. Now, so what this gave us is marginal improvements in quality, because the most complex features, the most involved features, they were still done at the very end. They were still aligned to the very end of the release cycle. But this was a very important step in our evolution, because we started looking at the world in terms of features, not releases. So all the planning became about features. When is this feature releasing, etc. When are we starting development? One interesting thing happened when we started looking at the world from this perspective. Developers reacted by creating feature branches. 20 features, 20 branches. Have you ever tried to merge 20 branches? I did it twice. This is the stuff you tell your grandkids about. Grandpa, tell us about the time you merged 20 branches. We learned our lesson pretty quickly. And what we learned also is that this showed us that we're coupled. What we noticed is that some teams move a lot faster, whereas others are moving slower. But we're still as fast as the slowest team in the entire organization. And I remember vividly this one release. We had a bug. It was about to sign off on this release. At this point, 600 people organization. We have one bug, and we can't find the source of this bug. And it's this one team in Bangalore, in India, and they're looking for this bug. We can't find it. They're working nonstop. It's Friday night. Everybody gets on the call. Probably 100 people on phone conference. VPs of engineering, VPs of operations, product. all the top brass. What are we going to do about this? Well, we're looking for the bug. It's like this 3-people team in Bangalore holding 600 people hostage. Right? And they're working 24/7 looking for this bug, but what are you going to do about this? You can't do anything about it. You have to wait for them to find and fix the bug. Well, so clearly we have a decoupling problem. What do you do when you have a decoupling problem? Call in the architects. So call in the architects, fix our decoupling problem. So we get in the room, and I was there, sitting in the room, and we sat there for quite a long time, and we looked at all the major system interfaces. And we came back with an interesting result. We said, you know, from the technical perspective, we can decouple. These interfaces are actually good interfaces. We're execution coupled. It's not about the technology. Kind of like this picture. The roads are there, allow you to move fast, provided you can figure out how to negotiate the intersections. Oh, it's not an engineering problem. We can plan our way out of it, right? How did that work out? Enter Soviet-style planning. Weeks of planning before each release. All the engineering VPs and directors all get into a room and start planning. Coming out of that room, this is one quote that I caught from a director of engineering. Any guesses as to what those two values are? So one is clearly estimates. Estimates are just taken out of thin air. Second one is resources. He says, okay, so there's 90 people reporting to me. What does that mean? Can I enter them into a formula and compare it to some other fictitious number? So life sucks. We try all these things, right? We try to go about it by the book. We talk to external consultants. We read all these articles. We try our best. We put our heart into it. And we're still not seeing any results. Still releasing 3 times a year. Still poor quality. But then there were a couple of glimmers of hope. September 2010, we have one of our ad servers goes into production. And one of our main ad servers, it's deployed to 6,000 machines. They worked on these features for a couple of months. They feel good about them. QA sat on these features for months. They feel good about them. It's rolling out to production. Now, it has to be done carefully. So 1% of traffic looks good, 5% of traffic, 100% of traffic, and then it broke. Rollback. Rollback, take your best engineers, put them on this task, find the bug. It takes them 3 days. They find the bug. It's a gnarly bug. 200,000 lines of C++ code. This bug only appears in production. Found the bug, takes them a couple of days to fix it, test it, looks good, send it to QA. QA spends several days fixing it, give it to Ops. Ops will roll it out. 1%, 5%, 100%, and then it broke. Repeat 6 times. So finally, they launched it to production without a rollback in December. 3 months later, 3 months of delay of their features. Customers aren't happy, product aren't unhappy. 3 months of delays for the next feature set. 3 months of their best engineers' time wasted. That was a wake-up call for them, because 4 times, the normal 4 times, was not dramatic enough. That was a wake-up call, and the truth is that they've been trying to make things better. They've been trying to focus on QA and this and that, and it's just not working, and it only got worse. So here I show up with my snake oil, continuous integration. Try continuous integration, it will solve all your problems. Now, I realize not everybody's an engineer, so continuous integration is this idea that you keep your build in working state. And to do that, you set up a build server, and you make sure you run the builds there all the time, make sure that the builds are working. Now, we had a build server, it doesn't. Nobody was paying attention to it, so the builds were always broken. So in January of 2011, we get together with this team, and they committed. They said, okay, we're willing to give any snake oil a try. We commit to keeping the builds working, and we commit to writing unit tests for all new code that we add. July of 2011, so 6 months later, they go to production with the new feature set. Same thing, 1%, 5%, 100%, and they did not have to roll back. For the first time, ever. Since July 2011, they're still running, still in production. Since July 2011, they had exactly one rollback. And it was not even software quality related, it was something else. So we said, aha, continuous integration is a powerful thing. That's going to be part of our success. The second thing that gave us hope was Scrum. We tried Scrum on several teams. We tried to pilot it on something like 6 teams, and it did not work everywhere. But where it worked, we really liked it. We liked the focus on customer. We liked the developers in QA and product, they're all working together. And people seemed happier on those teams. So we said, okay, we're willing to do it. Scrum and CI, go for it. Go for it. We mandated continuous integration for the entire organization. Got all the managers together and trained them on CI, Agile, and managing technical debt. Established communities of practice. Brought in external consultants. Release planning sessions, 200, 300 people. Massive release planning sessions. Imagine this entire building full of people drawing stuff on the walls. Scrum of Scrums, Meta Scrum, Portfolio Kanban, Impediments Clearinghouse, Agile Council tools. It's all about the tools, right? Live still stuff. Still releasing 3 times a year. Still poor quality. And at this point, I think a lot of us were ready to give up. You know this feeling, you wake up in the morning and you don't want to go to work. I hope you don't know this feeling. But you put all of your heart into this. You try so hard for several years, and you're not seeing the results. Things are as bad as they were several years ago. And now, so now this is several years later, looking back at it, it is so clear to me that you cannot iterate your way to a transformation. You need something bigger. Fire. Change everything but your wife and children. In 1993, Chairman Lee of Samsung dumped a bunch of Samsung cell phones in front of the factory where they were manufactured, poured kerosene over them, and lit them on fire. And when the fire was done, he rolled over them with a bulldozer. He sent those phones just a couple months later to his, prior to his friends, and those phones were not working. He went to New York and he went to visit electronic stores, and he saw Samsung products were in the back of the store, and in front of the store were the Panasonics and Sonys. He brought all of his leaders together in Frankfurt, and he delivered what is known as Frankfurt Declaration. He spoke for 2 days, and one of the things that he said was, change everything but your wife and children. Everything about this company is going to change. This is considered the pivotal moment in Samsung transformation. This is what they made, what made them a multinational and global powerhouse that they are today. They didn't have to do it. They could have remained a local powerhouse within Korea. They were doing great. The government supports them. Everything is great. They wanted something bigger. So he manufactured a crisis, in a sense, by lighting those cell phones on fire. We did not need to manufacture a crisis. We had a crisis in our hands. Our house was burning. This is 2011, 2012. We had something like 5 CEOs in 18 months. People were leaving in droves. Nobody was really working. People were disengaged. And we've all heard this phrase, never let crisis go to waste. What does it actually mean? How do you take advantage of a crisis when it's so bad? And it starts with a decision. You have to ask yourself a question. Are you in or are you out? I was working on the advertising systems, and we could have exited the ad systems altogether. This is not our core set of products. We could have outsourced it, or we could have stayed. Those were the choices. So it took real leadership to make this decision. 2 engineering leaders, and we interviewed both of them for this presentation, they made this call. They decided that we're staying, and we're going to change everything about how we do business. And to them, this is what it felt like. It felt like making this jump, leaving the terra firma behind, and leaping. Scary. Takes real guts. We interviewed them for this presentation, and one of them said this: strategy doesn't self-organize. Sure, I can jump off the cliff, but 600 people in the organization, or at that point probably 1,000. What are we going to do about it? I can make all these high-level decisions, but how are we actually going to make them a reality? So they brought in all of the engineering leaders together in a room. It was about 50, 60 people. And they said, so managers from development side, managers from product side, our technical leaders and architects. And we sat there in a series of meetings, multiple meetings over multiple weeks. And at the beginning, those two leaders stood up and they said, things will change. We will radically change things. And there are certain variables that are not variables anymore. Certain things will change. The rest is up to you. You get to define how things are going to work out. We need a strategy of how we will transform. And we sat there and we talked about it. And a lot of people left. A lot of people said, this is not for me. But those who stayed really determined the strategy for this business unit and eventually for the company in a couple of years to move forward. And they're the current leaders of the company. So this was the strategy that we came up with. Number 1 point, focus on speed. It's all about the speed. Not about Agile, not about CI, not about anything. It's about delighting your customers, moving fast, and delighting them even more. The rest doesn't matter. One team. It used to be that developers code, throw it over the wall. QA does their thing, throws it over the wall to operations. We said one team to rule them all. Buck stops with you. No more throwing stuff over the wall. One team. The thinking behind this is by throwing it over the wall, you create a moral hazard. Developers don't feel the pain of what's happening in operations, or the pain is delayed. It's not very immediate. So the thinking was by eliminating this moral hazard, developers will become more responsible for the quality of the software. That was the thinking.
Did you mean one Scrum team or one team of all engineers?
Meaning specifically we eliminated release engineering department and we eliminated QA department. Decouple for real. Remember this picture with end-to-end environment? We said we're going to do this. Everybody goes to production immediately. We looked at our bugs in end-to-end environment, the ones that we found in end-to-end environment, and we figured out that most of them should have been caught before. There was no reason for them to be caught in end-to-end environment. The value of that environment is very low. The cost of that environment is very high. Let's kill it. Now, of all the decisions, this was the most controversial and the scariest. It feels so comforting to have that environment. I'm going to throw it over there and somebody, not me, is going to certify that this looks good. And now we're pulling that rock from under them. It felt scary. It was scary for all of us. And we looked at a lot of data to convince ourselves that this is going to work. And we will see if it did work. We committed to continuous delivery. And continuous delivery is actually not precisely defined across the industry. So let me define it the way we define it. We define it simply and strictly. Commit to production without humans. Commit the code. I've been saying this a lot of times, and I've been telling people, no one button pushes, no setting and checking, none of that. Commit the code, it flows to production without human intervention. People still don't get it, so I decided to illustrate it. Developer, continuous delivery pipeline, production. Humans allowed where typing is happening, no humans after that. So the thinking behind this was, we saw how powerful continuous integration was. And continuous integration deals with just the very first box of this entire pipeline. And we thought just logically, if you automate the rest of the pipeline, the results should be even greater. Besides, we also thought that as we speed up, many humans cannot catch up. If you're moving super fast, if you're moving like that bullet train on the first slide, humans cannot operate at that speed. Only computers can. So that was also part of the thinking. We needed a process to produce software. We knew that we needed a process. It was just not going to happen by itself. By that time, we had enough experience with Scrum. We thought that Scrum fits the bill, more or less. So we chose Scrum. We reorganized. We had a large organization, at that point close to 1,000 people. The thinking was that we will break up into smaller teams, we call them pods, into pods. And pods would be 40 to 50 people, so that everybody knows everybody within the pod. So you can actually make stuff happen, because everybody knows everybody. Developers and product inside the pod, Scrum teams inside the pod, and each Scrum team is 7 to 10 people. And pods are going to be judged on one thing. They're going to be judged on how fast and how well they deliver software. The expectation is that you will deliver software a lot, and it will be of high quality. Now go and move. Summarize. Focus on speed. One team, decouple, commit to CD, agile, reorg into pods. And I imagine that a lot of people that are going through a transformation, they will see a list very similar to this one. But one thing is missing, and I would expect to see it in most cases. And I would expect to see a re-architecture bullet point down there. In order for you to decouple your architecture needs to allow for it. Your interfaces need to allow for it. Now, perhaps we were lucky, or perhaps it's just the nature of building scalable systems. We did not have to do it. We looked at our architecture again, and we decided that it's good enough. We can decouple with it. So with this, we went ahead into execution mode. Now, strategy is a very high level thing. A lot of things had to be figured out along the way. And we did not stop, and we did not wait for those things to be figured out. We just went for it. So this is our release schedule from the year prior to the transformation. 3 releases per year, around March, June, July, and typically before the holidays in November. For multiple years, that was the cadence. So enter the year of the transformation. We have a release schedule for March. The decision by the leaders to change things happened around February. Now, they did not put it in motion until the release was out. This was very deliberate. Wait for the release to be out, and during that low level of pain, let's put things in motion. So we had these conversations between all the engineering leaders while the next release was happening. So the release, we pulled it forward a little bit into June. So it happened in June. We were ready to execute. And as soon as that release was out, we went into full execution mode. So this was the agenda for a team training event. So we trained something like 600 or 800 people in 6 weeks. So people would show up. We hired external consultants, and we had some internal people. People would show up. This would be their agenda. Intro to Scrum, get to Scrum, about an hour. Name your teams, set up a working agreement, do a definition of done, work with your product on your backlog and sprint planning, and tomorrow you're starting with your new team. That was a shock for a lot of people. In fact, even for my team, I showed up, and when I heard you're starting tomorrow, I knew that this was going to happen. It was shock for me still. But this is real. So tomorrow we started rolling. Some pictures from those days. You see, first it cross hands. People are not really convinced at the beginning, but pretty soon they get into this conversation. They start working on their team agreements and product backlogs and sprint planning. Within just a couple of months, we started seeing small releases show up. Now, this was a scary couple of months, because you're sitting there thinking, is this thing going to work? Is this thing going to work? Meanwhile, your but business and customers are screaming, you guys are not doing anything. What are you doing? Why are you sitting on your hands? We had a larger kind of release still, end-to-end-ish release in November. And the plan was, after this release, we will dismantle the end-to-end environment. Now, this is 6 months into it. And you know how in Lord of the Rings, they almost defeat the evil, right? Almost. And then it comes back. They didn't quite do their job. So it felt almost like this, because we made the decision 6 months into it. We're ready to dismantle the environment, and all of this stuff comes out. All these people come out of the woodwork. What do you have to do, really? Let's revisit all of the decisions that we made 6 months ago. And things are improving. We think that things are improving. Why remove this safety blanket? And again, it took a lot of guts and leadership from our leaders to stick with this decision and to overrule all of these fears and to actually dismantle the environment. So it happened. And after that, shortly after that, we had our first true continuous delivery pipeline, commit to production without humans. Did not happen immediately. We did not have enough infrastructure for it. We had to set up a team that developed the necessary infrastructure for this to happen. It took, again, about 6 months. And then within a couple of months, we were operating at about weekly releases. And another couple of months, teams were releasing whenever they felt like. As continuous delivery spread, people were releasing, many teams were releasing daily. Most were releasing, I think all of them were releasing multiple times a week. About 12 months from the beginning. It did not happen overnight. It felt like we're turning the corner, when we started seeing weekly releases. And this is where I felt like we finally succeeded. So let's talk about, I introduced the value add slide in the beginning. I talked about value. So initially, with these 3 releases per year, you're adding value in a very step function type of way. As you introduce small releases, you see much smaller value add, but assuming that you're actually adding values, again, big assumption, but much more frequently. And eventually, you start seeing a picture like this. Pain. What happened to pain? Did it go down? So we see that roller coaster of pain going there with those releases. It did happen again with that larger release, probably not as acute, but it did happen. And really, I think we broke through a barrier around weekly releases. That's where it felt like it's different. It felt like we're not operating in the same level of pain. And today, it's very low. Production issues are almost non-existent. People, you know how the story about boiling a frog? Today, engineers would not be able to tolerate that level of pain. Never. They would quit before they experience this pain. It's not that we don't have problems. We have problems. But it's like free running. You see an obstacle, you run around it, or you jump over it. You figure it out, and you move on. We started with by-the-book Scrum. And I think it was very important for a team that operated in a very waterfall fashion for many years. We needed to develop those muscles, those agile muscles, figure out how to do things, understand the values behind agile, behind Scrum. But as continuous delivery spread, most people abandoned by-the-book Scrum, and they started taking very reasonable shortcuts. And at this point, most people don't do Scrum. It looks more of like a continuous flow Kanban-like. Because with continuous delivery, Scrum is almost like a series of small waterfalls. You know, you finish coding here, then QA comes in, then you release to production. With continuous delivery, you're in production in 3 minutes, 5 minutes, maybe an hour, 2 hours. Scrum feels artificial. So a lot of people, what they do, a lot of teams, they just operate in a very continuous fashion. They still have the cadence of retrospectives, cadence of demos, but in terms of delivery, they're just continuously delivering to production. I think I lost focus on this slide. Scaling Agile. We've been talking a lot about scaling Agile in the industry. We like to talk about it as scaling Agile by not scaling it. We tried all of these scaling frameworks, and it was very quickly we figured out that we actually don't need them. We can operate just fine without them. So what you have those individual pods, they operate independently, they coordinate with each other where needed. They sometimes align in quarterly schedule, but then they just move on. There's no scaling framework. Agile was set up to be simple. What happened to it? Let's bring simple back. So results. We put all of this effort, we did all of this execution. Did it matter? What were the results? In short, great success. Speed increased dramatically. We used to launch 3 times a year, you saw that. We started seeing, when we were done with ads, we started seeing teams doing several releases per week easily. Many teams did daily releases, some teams did multiple releases per day. I do not have hard data for ads. But then we took this data and we sold this to our CEO and we said, hey, we have to do this for the entire company. And so we did the same thing for the entire company, implemented continuous delivery for the company. And I do have stats for that. So 5 months it took us to do it across the company. We quadrupled the number of production pushes. And quality, what happened to quality? Traditionally, you have to trade off speed with quality. You speed up, quality drops because you cannot keep up with that speed. Remember the promise of continuous delivery. You automate all of those tasks, you'll be able to catch up. The quality improved. I was hoping for dramatic improvements in quality. They were not as dramatic, but they were very much noticeable. And they were especially noticeable for those huge production bugs that we used to have. We used to have 3, 4 of those massive production bugs every year, or every week. And now they're a thing of the past. Engineers don't even know about them anymore. When we were rolling this out across the company, one of the teams was very much on the fence about it, production engineer. But anyway, we went with it, and a couple months into the process, I get this email from the VP of production engineering. I read this, and I said, cool, what is change success? He said, when we deliver to production, new software, if it breaks in 24 hours, that's a change failure. And if it doesn't, then it's change success. And they used to, 100% change success is just unheard of in their world. They started seeing this. They became converts very quickly. This was not, we did not go after simplifying architecture. This was not our goal. But it makes sense that it happened. When you release infrequently, when you release monoliths, monolithic architectures are okay, they work for those use cases. But as you start speeding up and everybody's moving independently and moving fast, naturally things start to break down to smaller independent chunks. So over the years, I saw this with ads and now I'm seeing it with the rest of the company, started seeing smaller chunks, simpler architectures, much more decoupled, much smaller components. And 52 weeks of value. No more stabilization, no more QA cycles, none of that. No 4-week releases, just code and it's in production. 52 weeks of value. If we could only stop those meetings from happening. And developers are happy for it. And some of them are high, I guess, too. We actually did a survey, or Ed did a survey when we came in, and yes, sir. So we have numbers to prove the developers are happier. Shipping way more frequently, with way less cost, higher quality, and having a lot of fun doing it. Now, don't get any wrong ideas. This cost us a lot. This cost us money. We hired external consultants. We actually paid for the tools initially, even though we abandoned most of those tools eventually. We invested into platforms. We took 17 engineers and we said, we will be building continuous delivery platforms for the next couple of years. And we had to postpone multiple features, important features. We had to have very tough conversations with business about that. And it cost people blood, sweat, and tears. It took a lot of hard work from a lot of people. Astra Peraspera. Do you guys know, does anybody know what this means? Means, it's Latin, means to stars through obstacles, through difficulties. We used to sign our emails with this phrase, because how else are you going to get to the stars? 43 days. Fast Company published this article several months ago about a project called Moneyball within Yahoo. The project was at this point a couple of years old, so it's kind of old news, but we kind of unveiled it. We finally unveiled it. 43 days that it took to build this product, and it became a $1 billion product. So it was a brand new advertising product. Native advertising was a new thing several years ago. We went after it. And in 40 days it was done and it became a $1 billion product. And I have a video to show. No, it's not 20%.
20.1 started in March of last year. We essentially got a call saying, hey, we have this project going on. It's confidential, but show up in the office on March 15th. The mandate we got from Arista was we're rolling out this stream across the different Yahoo properties, and we need to monetize that stream. And we had to do it in 45 days.
45 days. And it was a brand new advertising product from scratch.
We were all in this enclosed space. People were only focused on the project. Essentially, everything I needed for the core team, I had the team right there.
The density in that room is high, the noise in that room is high. There is continuous design going on. You need something from two guys, you just scream out loud and you get a response within 30 seconds.
One other thing that was very different from a technical perspective was we built the continuous delivery pipelines in the first week of the project, which means when we checked in the code, it made it all the way to production without anybody doing anything manually.
So it really gave us that fast feedback loop to show whether features were working or not, and it allowed us to make refinements really quickly.
If we did not follow the CD methodology that we did, this entire project would have taken at least 5 to 6 months.
The result was that the team worked really hard and delivered a version 1 in 43 days. We launched it to market and we grew the revenue runway to $100 million within 3 months of launch.
The results were extremely positive, and we're very happy that we were able to make a meaningful contribution to Yahoo.
So this is what they did. Let's talk about this. So on Friday, the decision was made on Friday, we're going for it. On Monday, all the developers were identified, and on Tuesday they started. They all piled into one room, developers, product, operations, all in one room. First thing they did was to set up a continuous delivery pipeline. We had the infrastructure at that point. It allowed us to do it. So within the first day, they were in production. Just think about it, in production on day 1. From that point on, it was all up to business to decide when we're actually launching. If you want to launch with this Hello World program, if you want to go to market with it, it's your decision. Engineering is ready. No more unpredictable cycles. You're in production, always. You saw their, this is not their test board, but they had something similar. So very much in continuous flow. Every day they would have a sync up. And it's interesting to observe because we don't dictate any of this, obviously, across the company. But across the company, people mostly meet in the morning, 10 to 11 or so. This is when people have their daily sync-ups. For whatever reason, this team held them at 3:45 every afternoon. And I don't know why. That's the only situation like that I've seen across the company. Every week there would be a big demo, and a lot of people would come in. And there would be beer and wine and pizza and stuff like that. No Scrum, none of that methodology on top, just move fast. And I already mentioned, they're in production on day 1. At some point, business decided, 43 days has passed, we have enough features, launch it, go to market. So this is what we observed with this team, and this is very typical of teams that are moving in this fashion. They don't branch. Right. In fact, every single team that I've seen that implement continuous delivery, they stop branching. You only branch because there's a difference between what's being worked on and what's in production, just in case something happens in production. If what you're working on will be in production in several minutes, there is really no reason to branch. There's no bug queue. It's not that they don't introduce bugs, they introduce bugs, but as soon as you introduce a bug, your pipeline breaks and it has to be fixed. There's no reason to enter that bug into any kind of system even, you just have to fix it. So there's no queue. Naturally, continuous delivery leads to developers doing a lot more unit testing. That just happens naturally, which leads to higher code coverage, hopefully leads to good things. Cyclomatic complexity, if you don't know, is the number of independent execution paths that can be taken by a function. And higher cyclomatic complexity leads to higher maintenance cost of the code. This is also known as McCabe score after the McCabe paper published in 1979. Low cyclomatic complexity is good. Typically anything under 10 is considered great. So these teams were running in like 4 to 5 range. Excellent cyclomatic complexity, very maintainable code. 43 days, $1 billion. And they're not unique. We have developed a lot of products like that. Most of them you have never heard of because they died. And that's fine. That's what we want to do. Right? We want to learn. We want to launch these things to production. Like if they don't work, we'll take some pieces of them that do work and we integrate them into some other new project. So this is very typical. Just walking around the office. So this is just a summary of the model. Aggressive timeline, collocate, CD and day one, Kanban or continuous flow, daily sync up, and a weekly demo. That's the recipe that all of our teams nowadays follow when they work in new projects or even on existing projects. So just walking around the office, we just took our phones and walked around the office and started taking pictures. There are boards everywhere. If you showed this to me 3 years ago, I would not believe you that this is our company. Boards everywhere, people just doing stuff, going very creative with boards actually. So this team, so you can see open space, so teams are free to move their desks around in any way that they want. This team set up build monitor, so this turns red when the build is broken, and they also have some information in that thing. I don't know what it says actually. Other teams, this is from Taipei. So in Taipei they set up these orbs. So in the office they have orbs all over the place. The orbs turn red if the build breaks. We're not perfect by any means. We try to be good at what we do. We try to get better. We try to improve. But we've made some progress over the past couple of years. Lessons that we learned. Set some shit on fire. If you have a crisis, leverage it. If you don't have a crisis, perhaps create an artificial crisis. It really helps. Leadership matters, and it matters a whole lot. There is this narrative in Agile that leaders should just step aside and let the people do their stuff, self-organize. And there's a lot of truth to that. But it just doesn't happen by itself. The role of the leader is different. You're not a micromanager anymore. But your job is to empower your, I just said the E word. But yes, to empower your people, to create an environment for them to succeed, and to make tough decisions and to be a leader. Focus on speed. It's not about Agile, not about any of this stuff. It's all about delighting your customers, moving fast and delighting them even more. Speed versus quality is a false choice. Continuous delivery allows you to have both speed and quality. Coupling is so comforting. It's so easy to couple. And it's so tempting. Just remember this. If you couple, you die. I love Scrum. I love Agile. If you find, but sometimes it becomes a religion and a ritual, and I don't like that. If you find ways to improve process for your own situation, for your own needs, and you're not sacrificing quality, you're not sacrificing speed, who am I to tell you otherwise? Just do whatever feels natural. It's supposed to be simple. If it's getting too complicated, it's time to stand back, reflect, and perhaps rethink some things. So let's bring simple back. Yahoo is 20 years old. This year we celebrated our 20th anniversary, and we set Guinness World Record for the most number of people yodeling at the same time. We beat the previous record set by us 5 years prior. Again, we're moving fast, just like in the old times, and again, we're competing. We haven't won yet, but we're in a position to compete. And our billboard is back. Back in the same place in San Francisco. So if you're ever in jail, our story is not unique. I'm sure many of you could tell a similar story. Or maybe you're going through this process right now. Or perhaps you're just contemplating going through this process. There is a light at the end of the tunnel. It can be better. And next year, hopefully, you'll be here telling this story. Ad astra per aspera. Thank you. So do you have time for questions?
Yeah, we
Plenty
do.
of time?
Q&A?
Yeah.
Work for you?
Go ahead.
One, In your continuous deployment, do you deploy to a subset of your customers? Do you have a model like that, or do you deploy to all of them at once?
So, did everybody hear the question? Okay, so just to repeat for the video, the question was, do we deploy to all customers at once, or is there some kind of progressive rollout? So one thing to understand is that we do not have a monolithic code base. Everybody, so each individual launch unit has their own code base, and they're deploying independently and individually. So we leave a lot of these decisions to the teams of how they deploy to production. So if you're if you're an experimental product, you can actually go out with being a lot less sure about your quality and be a lot more aggressive about your rollout versus, let's say, a net server that deals with billions of dollars, right? So we allow teams to make these decisions. So on most teams, they do have a system for progressive rollout. Most teams will go through either some percentage of traffic going to a non-production environment, or perhaps they deploy to 1% or 0.1% of production and then slowly roll it out. So we do have the infrastructure that allows for it, and most teams use it, but not all.
And is the rollout itself part of the continuous, are the gates part of the continuous deployment?
Yes, so the entire thing, so from commit to 100% rollout is automated.
What sort of data did you use to convince the executive team to make the switch to continuous delivery?
So the question was, what data we use to convince executives to switch to continuous delivery? So executives are actually, that's quite easy. The data, you just implement it in one place and you show them the difference in quality in terms of bugs, and you say the team is moving faster, executives are sold. Now, they'll ask you to actually go and implement it, and that's a lot harder. It's much harder to deal with line-level managers or whoever decides where the resources are going to be allocated. That's where the rubber meets the road. And those are the harder conversations to have. And even developers can be very conservative. A lot of developers were against it. So it took a lot of convincing and a lot of arm twisting.
I'm curious about the testing practices, and you were talking about unit testing kind of started to emerge naturally when you had continuous deployment. So it sounds like you don't necessarily equate full automated testing and continuous deployment. So I'm just curious about your thoughts on automated testing and the transition, the evolution of that.
So we tell teams, so the question was about how do we automate testing and the mix of tests and stuff like that. So we tell teams that from commit to production, you cannot have humans. You have to be confident in whatever you deploy to production through automated testing. We do not prescribe a mix of unit tests versus functional tests versus whatever. So what we see is that if it's a brand new product, people will naturally figure out that unit testing is the most efficient form of testing. And 90% of your tests will be unit tests and maybe 10% performance tests, functional tests, stuff like that. If you start converting legacy, by the way, continuous delivery is the cheapest when you do it with a brand new product. It's very hard to convert legacy because you already have a lot of manual tests in place. When you start to convert legacy, typically, in our case, there was a lot of automated tests already in existence, and they were all functional and integration in nature. So what people did is they plugged those in. So with legacy products, we saw a reverse. We saw 90% of tests were functional integration and 10% were unit tests. So we don't prescribe these mixes, they just naturally happen. Whichever way you go, all we ask is you don't have humans in the pipeline.
Was it difficult to make the leap from having a manual testing department to just making the leap when the automated test passed?
So the question was it difficult to convert from manual testing department to do the leap, to go through the leap? It was difficult. Theoretically, the tests were supposed to be automated already. because that's what we expect. Supposedly we don't hire monkeys who will just sit there and type stuff. We ask people to automate stuff. In reality though, that wasn't the case. And I don't think it's inherent to the problem, to the domain. But the people that we had in the QA department were primarily manual testers. So what happened was, during this transformation, about half of them left. And half remained, and we said, oh, you're now developers. So deal with it. And of the 50% that remained, about 40% was kind of left over the next year or two. But the 10% that remained are just awesome. And they became awesome developers, awesome managers, awesome leaders. Yes?
So, one sort of weakness that I've noticed with a lot of developers that I've worked with is they're really lousy at testing their own code because they tend to stick to the sort of the design narrow path, right?
Yeah.
And so they're not very good at sort of poking it and prodding it in ways that maybe they had never thought of when they designed the thing. So how do you address that when essentially it kind of sounds like they're responsible for testing their own code the day that they go commit it, and it basically goes live at that point. So how do you sort of bring that variability of testing and robustness verification into the process?
Yes, so the question was about different points of view in terms of what to test. And developers could be quite lousy at testing their own code and thinking about all of these possibilities. So first, I want to talk about our bet was that developers, now that they don't have the safety net, they will be a lot more conscious about what they do. And as the result, they will test their code a lot more and the quality will be higher, and we will not just come crashing down. Now that was a pretty scary bet, but we made that bet. And it worked out. There was one or two teams across the company that just shipped untested code and learned very quickly not to do it again by themselves. So for the most part, it worked out. When it comes to unit testing, I think, so there's a difference, I think, between functional and unit testing. With unit testing, it's not actually the testing, right? It's a spec for how your code is supposed to work. So if you do it properly, there's not a lot of points of view to be had about your unit tests. But there's a lot of points of view to be had about functional tests. It is true that people do not necessarily think of all possibilities, that all possible scenarios that can happen with the product. What we encourage people to do is to bring operations and developers and product, everybody together, and to just brainstorm and have these conversations out in the open about various possibilities. And ultimately, the product decides, this is an important scenario, do test it, or this is not an important scenario, do not test it. And what really helped there, and we don't do enough of it, but teams that do, it really helped, is Cucumber. So where you use Cucumber properly in a declarative form, where all of your acceptance criteria are described in Cucumber format, then there's full alignment between product and developer and customer, and you can have these conversations. Are these scenarios sufficient to accept this product? And the conversations are, since you have this one artifact in which everybody can align, it's very easy to have those conversations. So I don't know if it fully answers your question, but I think what I've seen is at the end of the day, it works out, it works, but it does require people talking to each other. Yes.
In the slides, you showed a lot of manual boards, like Kanban style
Yes.
boards and things like that. Was it preferred to do things manually on the wall rather than to use tools like Pivot Tool or things like that?
Right. So the question was, why do people use boards, or do they prefer boards over tools? We did have tools for a long time, and even now we have tools. And maybe a couple % of teams, so we have hundreds of teams. Maybe a couple of them use electronic tools. Most of them, so the tools are there, but they prefer to do it on the board. It's easier that way.
So they're co-located, and if they're at home, they
Yeah,
can't.
so they're co-located, and as soon as you have somebody external, you have to use the tool, pretty much. That's my experience. We have one team that they set up an elaborate webcam, something like that. It seems to work for them, but the guy on the other side is also kind of crazy. So It seems to work for them, but for most teams, well, in my experience, once you have a personal, remotely, you have to use the electronic board. Yes.
Where does visual or usability testing come into the continuous deployment? That seems to require some
Right.
human judgment.
So the question was about visual and accessibility testing, or acceptance testing? Yeah.
Usability testing.
Usability testing. So a couple of things about this. One is there is once you have your requirements defined, you can certify that this product acts according to those requirements. The question is, when do you know? Certain cases you say, okay, this design needs to be stunning. I want a stunning design. How can you judge this? You can't. So you have to have experiments running, and there we say even don't do continuous delivery, don't do any of this. Rapid prototyping is where it's at. Just do a lot of that, do a lot of experiments, and then throw that code away. And then once you make a decision, go with it. After that experimentation happens, there are sometimes situations where you need to expose your features to a set of customers or something, to like train them or do something about it before general public sees it. So we use a lot of what we call flexible feature flags. So the feature, they control whether the feature is on or off, but based on some kind of runtime condition. Could be phase of the moon or day of the week or IP address or username or whatever, you name it. So we would enable those features for specific accounts, and features will be displayed, and that's also how we can do end-to-end testing in production if we need to. Yes.
Just to sort of back up a little bit, I mean, can you give you gave one example of the type of product that you were releasing, which was this ad serving system.
Yeah.
Can you just give some other examples? What were these 3-time-a-year type blocks, and then how did they maybe get broken up into these smaller delivery pieces?
Right. So within our environment, we have a lot of. So we have several big business units, and within business units, you have a lot of individual launch units. Right. Launch units are pieces of software that launch together. And traditionally, when we were in that slow schedule, they were massive. And over time, they just get bigger and bigger because people start orchestrating with each other, orchestrating launches with each other, and those pieces become bigger. So we saw it across the board. You name any Yahoo product, it was pretty much in that state.
So what were some examples of something that would get launched? Again, I'm not that familiar with the office,
right.
Honestly.
So anything. So in our cases, we had on one side we had UI, traditional UI, traditional API, kind of Java stack, and we had C++ ad servers primarily at that time. A lot of big data pipelines running on. This was prior to Hadoop. So, but nowadays they will be running Hadoop. So you can take pretty much any of our software. So name Yahoo products, news, finance, sports, messenger, mail. All of them were lined up. Right? So they were not all running the same type of software, but very similar. So there's always a UI, there's always a web page, there's always some kind of a high traffic server, there's data processing, there's analytics and reporting, stuff like that. I don't know if I'm quite answering your question, but I can also answer it differently perhaps. When we went to do it across the company, we ended up dealing with UIs, we ended up dealing with APIs, high traffic servers. We even automated pushes to network switches. So across the board, we saw it all. And at the beginning, of course, the first reaction, oh, it works for UI, but it will never work for my system. Or it will always works for API, it will never work for UI. But eventually we figured out ways and patterns to do it across the board for various types of software.
I wanted to ask a question about more on the market with Yahoo. Where is Yahoo now positioned in the pie with the competitive competition?
The question was about Yahoo marketing position, and I actually don't know. I think it probably depends on the product. In some cases, we're competing very well. In some cases, we're number one in the market. Some cases, we're number two. Other cases, we're not playing in certain markets.
Do you have any differentiator, strong differentiators against those, against the competitions right now, or?
I think so the question was about our differentiator. And on the product side, I cannot answer that because I'm not a marketing person. But on the engineering side, I think ability to move fast is our differentiator. This is, in fact, this is kind of table stakes today. I don't think anybody actually pushes this fast across the industry, because we do have friends in big companies in the Valley, and we do know how they launch. They'll move fast, but not as fast. And I think this is our competitive advantage today until they catch up and everybody else catches up. Yes?
I'm interested to see how continuous delivery plays a little bit with the decoupling that you talked about. Because decoupling is about interfaces. If everybody pushes at any point in time, it means you cannot have backward incompatible interfaces, which means that you have to add new things.
Right.
And you cannot deprecate things until you make sure that everybody is not using anymore.
Right.
That adds, call it tech debt, that adds hoops that you have to go through to maintain all that. Have you seen, you haven't been that long maybe doing this thing, but have you seen any of the recipes that you try to maintain that?
Yes, just to summarize, the question was about decoupling and the impact of decoupling and continuous delivery and how that works together. Yes, absolutely, decoupling is required for you to move fast like that. A couple of rules in our system is you cannot, one system cannot impose orchestration requirements in other systems. So that takes care most of the time of backwards incompatible changes. So you're expected mostly to change things in a backwards compatible fashion. When you do need to break backwards compatibility, you create a second version and you enter an end of life period. And then you deal with your customers individually and you tell them, okay, in 12 months this is going to go down. And that, unfortunately, today we do not have technical solutions for that, so it's very much a human type of interaction. You tell people, you send reminders, you call them, etc., and you tell them to get off of the old version. But yeah, we will be dealing with that quite a lot.
What about internal?
So this is internal.
You call it customers internally?
Yeah, so if I am a platform, then my teams that are using this platform will be my customers.
All right, well, thank you very much.
Well, thank you.